Welcoming Zentra to the stage, please. It's KJ.
Thank you.
All right, thank you.
Okay. Thank you everyone for joining this. My name is Kanji. You call me KJ, Dr. KJ. I'm the founder of Zentra, and I propose this new series called Miner Series. Okay, I think it's the key. It's a key to scale all the blockchains. We working on very fundamental blockchain series, and yes, make a change. About myself, I received my PhD from University of Liverpool last year, and my research main contribution is based on we found the first useful POW in the past 7 years, and we. According to we created a Miner series before I submit the PhD thesis. So Miner series is today's key to solve the existing problems. Okay, just imagine that this is an old wooden house, like a 2-floor wooden house. We are the current infrastructures, and what we need is 100-floor modern buildings. So can we do something like try to hard working to add some wood to extend the TPS to like 100 floor things? I think we need a new methodology, new material, more scientific tools to build that, to achieve that goal, more engineering, right? I think that's the key, just tear down these 2-floor buildings. That's it. So how do we do it? So we believe that blockchain is the minimum blockchain is consistent with 2 components. One is the consensus algorithm, another one is the ledger system. So go back to the Bitcoin, the consensus algorithm is POW, and the ledger system is UTXO, right? And going back to Ethereum, maybe extension from the Bitcoin, we see the consensus algorithm change to POS, and the ledger system actually becomes the EVM and its global state. So, in the science field, when you ask for a question, sometimes when you ask the right question, the answer is there. So, the question come to us yesterday is like, is there a blockchain simpler than Bitcoin? So, you look at this, it's already simple enough with 2 core components. But is there anything more simple than Bitcoin? Let's look at this axis with the direction of right is go to the more complexity of the Bitcoin. From the Bitcoin to Ethereum, we added the complexity. And in the future, we have something called maybe parallel virtual machine and DAG and the Z-case. That's increasing the complexity of the blockchain. But what we are suggesting is to make a U-turn, say we stop adding new features to blockchain, but we try to kill something, we try to remove something, make a U-turn. So here's our choice. To the consensus algorithm and the ledger system, if we want to remove one, then we have no choice. It's a ledger system. To UTXO, it's maybe like a very simple because it's basically like a add and minus, and if you check the negative, right? But for Ethereum, each transaction indicates a VM execution. That's very expensive. So what we need to do, Miner series is actually decoupling the consensus part and the execution. Usually, look at the before one. It's mixed because think about the sequencing. We have the member pools. We have a lot of transactions are waiting for be packed into the next block. So we miners first choose which transactions are going to be included, and second step, we need to do some verification, which is called the execution. So we validate which transactions are validated or invalid. We remove the invalid transactions. Then, okay, we must do the verify to include the correct transactions into the block because the block size is limited. The third one, we do an election, which is like many people are doing the 2 steps in parallel, but finally only one of the miners could have the right to create create the next block. So what we change is here. Consensus is like a sequencing. We do the same job. Then we don't check if the transaction is valid or invalid. We just do the election. Then we delay the transactions of the chain node. We put it delay out of the blockchain node. That's what we design, in this way. By doing this, we don't have a time constant, to finish the execution within like for example in Ethereum it's like 10 seconds, right? 15 seconds. So the benefit of that, since in blockchain node it's very cheap, we don't need to do the execution. So a blockchain node can include a huge amount of the transactions within one block. We can also do something like sharing technology, but it's open. It's open, Huge amount of TPS is possible. Then on the right, after a new block was generated, we can do the delay execution. We don't have the gas limit. We make the we can also optimize the speed, reduce the time by parallel execution. We can also make the complex application onto the blockchain. There we go. So this is the security part. Many people ask about the security part. So once we get the execution engine outside of the blockchain node, it's still a part of the together with the consensus algorithm and the execution. It's a bigger part of the blockchain system is there, but the execution engine is still publish the state root. It's just the difference is like we're not commit back to the blockchain header. That's the difference we're doing, and the security is mathematically safe backed by the state machine theory. So this theory is from the computer science, classic computer science, the state machine. So even like a famous project like Monad already agreed on us, because in their document there's one important thing that says like determined order implies a state determinism. Okay. So we made 1 month ago we made the proposal on Ethereum research forum, and we make it. And this is our theory. Yeah, it's not very long, but you can read it. This is Zentra. We are based on this theory. We create our product. It's an execution engine, and we ship with Python, with true Python. We work with existing blockchains. We are not a layer 1. We're either not a layer 2, but we are an execution engine. So we solve in Zentra. It also solves like a state exploration problem, because in Ethereum the size of a global state is keep growing. There's no way to make it smaller. But in Zentra we have the top limit of the global state of size. Okay, this is how we do the change. Oh, okay. This is my Twitter and our project called Zentra.
Thank you very much.
Yes, thank you.
Fantastic presentations. I think we may have time for one question if there are any burning questions. I think. Okay, fantastic, lovely. Thank you very much, Dr. KJ.
Thank you.
Thank you.